to is how is that drug going to be delivered inside the patient's body? Okay, so is it going to be injected, or is it going to be a pill, or is it some other way to get in the body? Then once it gets in the body, well, how is that pill going to be absorbed where it wants to go? Okay, and then what's the dosage going to be? Okay, so all those things are part of making drugs, and there's a lot of, it's not just science but engineering involved in making these drugs. So that's something that you guys can do when you finish Chem1B and get your degree and do what you want to do. Okay, let's go on question 2. Explain what happens when a can of soda is opened. And the CO2 goes out because, and what about the pressure? Does the pressure, when you open, does the pressure increase or decrease or stay the same? Yeah, the pressure decreases, because we know that the solubility of a gas, does it increase or decrease as the pressure drops? Yeah, so the solubility of a gas, let me write this down. So the solubility of a gas, okay, as the pressure decreases, so the solubility of the gas increases or decreases, is going to put it up, air going up or down? Okay, so the solubility of the gas decreases, that pressure decreases. And name 2 ways to get more CO2 to dissolve in water.
Cold water.
Yeah, so use cold water. Another way. Increase the pressure. The third way, which quite a few mentioned, is to use more water. Okay, so I accepted any of those answers. Okay. Now today in lab, you're going to be making ice cream, so I hope you brought your ice cream stuff today. Ice cream. Note that when you make ice cream, it's really, another way of looking at this lab is better living through chemistry. I don't know, I think most people like ice cream. Okay, so while you're doing this lab, what is the solvent in ice cream? Water. Yeah, so it's water. What is the solute in ice cream? Now milk is the name of a mixture. And then in milk we know that the solvent in milk is water. So what's the solute in ice cream? Okay, so let's write some of the stuff down. Okay, so we know that ice cream, the solvent is water. The solute. Okay, so what's the solute in ice cream? Salt. Okay, salt. What else? Sugar. Anything else?
Butter pecan.
Okay, butter pecan. Whatever your favorite flavoring is. What else? Okay, now cream is again a mixture in which the solvent in cream is water. But what else is in cream? Yeah, lipids and fat. See, a lot of the taste and the texture of ice cream comes from the fat. Anything else? Okay, butter pecan, chocolate, vanilla, whatever you like.
Rainbow sherbet.
Vanilla, chocolate chips, whatever you guys want to do. So that's going to be your salt. the freezing point of ice cream is? Yeah, so the freezing point is going to be less than 0. Yeah, less than 0. Now, can you predict what the numerical value of the freezing point is going to be?
Negative.
Yeah, because we know that if you have a sol used in a sol vent, that's going to depress the freezing point. And that means that you can use the equation delta TF is equal to I times molality. Okay, so what we want to do is, if you can estimate what the molality of the solution is, then you can estimate the freezing point of this ice cream mixture. So when you go to lab, if you start with about a pound of ice or 500 grams of ice, you want to calculate the grams of salt that are needed to lower the freezing point to whatever temperatures that it's going to be. Okay? So again, that's what you and your group are going to do. Starting with about a pound of ice, estimate the mass of salt you need to lower the freezing point of your ice cream liquid solution to freeze it. And of course, you'll try it and see if it works. Now, if you put your Ziploc baggie of your ice cream stuff in your rock salt and ice mixture, and it doesn't freeze, what should you do? Yeah, add more salt. Okay, so we'll see if that works today in lab. And then, in regard to the rest of the lab, did you guys get to the part where you did the thing with the sodas? Yeah. You guys get that part? Okay, so we got to work on that one today too.
So you did the ice cream first, or you finish the soda one up?
No, we'll finish the soda one first.
Okay.
I don't want someone getting like, what's it called? Brain freeze. Or, you get your ice cream hangover and you can't get your big stomach ache and you can't work anymore. So I don't want any excuses like that. You know? You can use that excuse for your next class. Tell your instructor for your next class, I've got a big stomach ache. I can't take too much ice cream. Okay, so what we'll start talking about for the next lab is chemical reaction rate. So let's just review some energy concepts. So we know that energy is involved in every chemical reaction. In Chem 1A, we talked about heat and thermochemistry. So we said that when heat is supplied, or when heat is gained, or actually when energy is supplied or gained, that's an endothermic process or endothermic reaction. When energy is released or lost, that's called exothermic. We discussed this last semester in Chem 1A. When bonds break, energy is required, supplied, released, or absorbed. Okay, so when bonds break, energy is required, supplied, released, or absorbed. Okay, so who says that when bonds break, energy is required? Okay. Who says that energy is supplied? Who says energy is released when bonds break? And who says energy is absorbed? Okay, turns out that the right answer is 3, energy is released. So when bonds break, energy is released. Now, let's look at the reverse. When bonds form, sorry, take it back. For part A, I made a mistake. When bonds break, energy is either required or supplied or absorbed. They mean the same thing. Okay, so again, when bonds break, like when you break a stick or break a pencil, you need to supply energy to break that stick or break that pencil. So again, when bonds break, energy is either required or supplied or absorbed. Those mean the same thing. Okay? Let's take a look at the reverse. When bonds form, energy is required, supplied, released, or absorbed. Rolando.
Well, I have a question about one because, like the nitrogen triiodide, you supply energy with a feather, it explodes, the bonds break, and the explosion occurs when the nitrogens bond and the iodines bond?
Yes, you're talking about this reaction. So nitrogen triiodide is this molecule, Ni3. Okay, so this nitrogen triiodide only took the touch of a feather, like you said correctly, to break these weak nitrogen iodide bonds. And then what formed in this reaction?
N2 nitrogen gas.
N2 and N2, which is this compound, and I2.